Great. Welcome, everybody. We've had a few technical challenges this morning with Eskom load shedding, but we should be good. So I'd like to introduce Sue van Rensburg, who's the Grasslands node manager. Sue has been the manager of the Grasslands node since it started in 2011. And she's driven the Maputaland Coastal Plain long-term site that we have forward and has been doing some very interesting work there, crossing into the socio-ecological space. And today she's going to be talking to us about some of the worker problems that they are facing up there. So Sue, over to you.
Thank you very much, and thank you so much all for being here today. I know your time is precious, so I really appreciate your attention. And so I want to start by asking, for how many of you is your research work important to changing society? Do you feel like you want to make a difference in society? And I hope to show you today that it's indeed necessary and also incredibly rewarding to try and initiate and do research that actually does have an impact on society. Now, when I embarked on my research journey, I saw science as a world of adventure. There were places to discover. I wanted to explore. I was really excited about the things that I could go off and see and discover, and beautiful places. And I wanted to really relish that journey of exploration and curiosity and discovery. And I really just wanted to learn about the world and how it worked, the natural world. And I've had the good fortune to work in some amazing places and to actually experience that. So that's been incredibly fortunate for me, but at the same time, the reality is that humans are a part of this ecosystem. We rely on ecosystems. We also impact on ecosystems in terms of the way we utilize the land. And of course, we all know that we are influencing the climate, leading to climate change. And the net result is that when things go wrong, people can lose their lives as well as their livelihoods. So given the challenges we face as society today, and particularly in South Africa and Africa, where there are extreme vulnerabilities in communities, the need for research work to actually have a constructive and positive impact on society is becoming increasingly important. And this is reflected in SAEON's vision. So we are aspiring to enable these world-class research platforms that can actually contribute to creating a sustainable society. And indeed, the NRF is also embarking on this journey and in trying to ensure through various frameworks, such as the impact framework, that research as a whole within the country contributes to both societal knowledge as well as it has impact in terms of its knowledge and societal impact. Now, as researchers, we're fairly familiar with knowledge impact. We think about, well, how many papers have we published? We know how we can advance the fields of knowledge. And some of my colleagues have indeed produced amazing products, such as guides that can help other researchers in their research work. And we can also see the discovery of new species. And this is the kind of stuff that keeps us curious. It's our lifeblood. It's what makes us happy, that journey of discovery and exploration. But what about societal impact? How do we ensure societal impact? What does this actually look like? Now, how many of you have written those proposals where we say, in the proposal, our work is going to help guide policy or influence policy, or it's needed for policy, or it will inform policy? I know I have, and I've seen many others who have. And the logic kind of goes that if I produce decent work with good proof, with a sound scientific background, I'll be able to give that knowledge upwards somewhere or make it available. And then the sensible thing is that rational people will take up this work and they will make sure that the necessary actions unfold. But here's my personal caricatured experience of that. Policy brief 101, right. CO2 is causing climate change, and this is really, really bad for all of us everywhere across the world. Okay, so the solution is pretty simple. We need to keep coal in the ground. We all know this. And alternatives do exist, and it's really a no-brainer, so let's get cracking. Right, no problem. But somehow, somewhere along the line, things get stuck. Either nobody listens, or they get sidetracked by what they think are bigger political issues around this. And then there's that assumption that the people in the upper powers, or in these positions where they have the agency to actually influence, are rational. And we know that we've come to question that assumption. So the bottom line is, while all this is going on, the most vulnerable suffer. And a few years back, it really started to get me down, this sort of feeling like we're doing this research work, but what impact is it really actually having? And at the time, we were starting to set up the SAEON Northern Maputaland Long-Term Research Ecological Platform in Northern KZN. And the key question, like in many of our other platforms, are what are the relative impacts of climate and land use on the ecosystem services that people rely on? Now, Maputaland, at that time when we started up, there were hints that the water table was declining. There was a lot of concern about it. And we really thought it would be interesting to have a good look at the system, knowing that forestry initiatives were also being rekindled within the region. So it's a really neat experiment to go and look and observe and see how these changes and how climate, if we could disentangle these various different effects. Now, most of you should know that the Northern Maputaland Coastal Plain it's a groundwater-driven system. It's reliant on local rainfall for recharge, so very sensitive to climate changes, as well as changes in land use. And it's got an amazing diversity of ecosystems in the area, and it also hosts South Africa's largest wetland, Lake Sibaya. And when I was working in the area, I was introduced to the Vazi wetland. Now, this is a 7,000-year-old peatland, and the photo in the picture, it was taken in 1965. Peatlands only form in conditions that are permanently wet. So we knew that this area had been wet, and there are a number of peatlands in the area that are around 7,000 years old. So there was obviously enough moisture and groundwater in the system to support the development of these wetland ecosystems. And my friend Sihle Bokuseni had set up a science center very close to this. She's a hydrologist, and when she moved to the area, she realized that many of the schools didn't offer science. And as a trained hydrologist, she wanted to use this wetland as a classroom to train students and learners and expose them to the journey of science and try and bolster their science literacy. So we, of course, went and put some loggers out there, and we started monitoring this peatland. And then we received a call from her in 2007. She said, "Please come, I need your help. My peatland is burning and I don't know what to do." So Lulu Pretorius, who works in the area, and Sipiwe, our technician, and myself, we hot-tailed it up there. And of course, when a peatland starts burning, it's incredibly difficult to put out these fires. They burn underground, they burn for an incredibly long time. And try as we might, various different groups of people tried, nobody could get any assistance or help to try and stop this peatland burning. So that's a 7,000-year paleo record, and all the carbon and everything up in smoke. And the trigger came when Sihle, with tears in her eyes, said to me, "That's it, that's my work done. There's nothing more left for me to do here." And I looked at her and I said, "Sihle, that's wrong. This is the time when our work actually starts. We have to do something about this, and we have to work together to try and find a solution." So what's causing this? Obviously, it's a decline in the water table, and there are these usual suspects. We know from research already done that eucalyptus plantations are having a significant impact on the water table. There's a bit of a debate as to how much. We know that plantations have increased dramatically in the last sort of 2 decades. And we also know that there has been below average rainfall with the most extreme droughts on record. So after the fire, we got together and we hosted a workshop, and you'll see the gentleman down in the bottom corner who I've met recently again at another workshop. And we spoke to communities about this, and basically what emerged is that people in the area are very aware of the fact that eucalyptus trees take water, and yet there is no change in practice. And part of the reason why there seems to be no change in practice is this perception, or the story we keep getting told, that there are no other livelihoods. Forestry is one of the only sources of income in the area, and we basically don't have alternatives. And if there were alternatives, then we might change, but they would need to be worth our while and make us enough money as the eucalyptus trees. So at that stage, I felt rather despondent. Even if we did all this cool eco-hydrological modeling and we got really good data and we could show the impact of various different vegetation types on the water resource, there was the sense that it still wouldn't have any impact on the ground, and people in the region would suffer as the water table continued to decline. Now, I pay my taxes and I don't really want to see them wasted. So I started thinking, what would need to happen to ensure that the research work we invested in actually had some kind of positive impact on the ground? And the big idea we came up with that I want to share with you is whether we could use an engaged research approach to help understand the context by immersing ourselves in the landscape, instead of looking at sort of through a microscope from the outside in, rather embedding ourselves in the landscape and using co-generative approaches to work with people in the region to try and understand the issues and come up with new solutions together. I was very curious to see whether we could discover emergent solutions by working together that perhaps if we were working in silos or working alone, we wouldn't actually discover. So that was our really big idea. And this is about shifting our perception and trying to understand other people's perceptions and understand what other people's views are, and opening ourselves to learning from others, rather than the sort of more traditional approach, whereas I'm the expert, I know what's right, and this is what you should do, because we'd seen other people doing that in that area and it simply wasn't having the desired results. So it turns out there is actually a theoretical framework, which is the social ecological systems approach. And now I'm not well versed in this, and I'm not a practitioner, but very simply, you have social systems that interact with feedbacks. You have ecological systems that interact with feedbacks. And when these interact together, you have what we call a complex social ecological system. And the Maputaland Coastal Plain is a typical example of that, because people's lives and livelihoods are very closely intertwined with the natural environment. So I had some nagging questions. How profitable are the trees really? And how many people are benefiting from them compared to other sources of livelihood? And does the impact on the water table actually have a negative or positive impact on other people's livelihoods? And how will the decisions that people make today possibly affect the future outcomes of the prosperity of the area, given the fact that we are facing climate change? And I was also very curious about what the real aspirations of the community are in terms of how they would want to make money if they did have access to alternatives. So that helped us conceptualize this project, which is now funded through the WRC. And I'm very, very fortunate to be working with an amazing group of collaborators from a lot of different organizations, University of KwaZulu-Natal. We've got Bruce Kelby on board, the University of Cape Town through the climate group with Ross and and Chris, and we're also working with James Blichno from Asset, and a number of people in SAEON, including Mark Pienaar, who's helped us immensely in developing this project. And we're kind of halfway through the project, so this is just a bit of a taster of what we're doing and what's going on, and some of the fun we're having in doing this project. So the conceptual model is we have climate, which influence hydrological processes. We also have land use decisions, which influence hydrological processes. And these all have impacts on sectorial and household income. Then we need to understand how people have coped in the past in terms of different climatic conditions. And that gives us some kind of idea of the shocks and the impacts on their household income and the net economy of the region. And using a big economic model where we integrate all of this, we can try and understand what the net effects are. Then we can try and do this for the future. So what would it look like if the future was warmer and drier or warmer and wetter? And how can we play with scenarios in a sort of a modeling approach where we work with communities to look at this and explore it and see, if I make a decision today, what will it look like in 2050 when you know, my child is you know, it's sort of a 20, where's my maths, about 30 years down the line. So the idea is to use this as a decision-making tool where we can play with and understand the impact of decisions made now on the net economy of the region. And it all starts by understanding the context and using co-generative approaches. So the idea is to work with the traditional councils in the area to do this, and we're working with 3, and so far we've already had 3 traditional council workshops, and I'll give you some teasers on that shortly. So essentially, for this to work, there are different component parts. We need the experts in the climate. We need information on land use and land use impacts on hydrological modeling. We also need to improve our understanding on aquifer processes. And then all of that needs to be fed into a surface model, which is the ACRU hydrological model, which Michelle drives. And then from that, it needs to go into a groundwater model where we get some kind of response. And initially we look at what is the status quo, what's currently happening, and we use that to help develop and benchmark the economic impacts. And then we do all of this again for looking at the future. So in order to do this, as I said, we need lots of help and lots of different individuals. So I want to introduce you to Tobeka, and she is an MSc candidate, and she's essentially working on different aquifer properties using all sorts of fancy techniques. We've been out there sampling fairly regularly, looking at aquifer properties. We're collecting rainfall samples with the help of some community members. We're monitoring the streams. We've been doing a lot of groundwater pump testing in the field. There's one of our interns, Nosihle, assisting with Tobeka. And basically, she's using all of this information to look at isotope studies, to look at how much rainfall do we need to sort of see a response in the aquifer, and how are things connected, and what kind of weather events are we picking up through the isotope data that are actually recharging the aquifer. So she's doing a lot of work on that, and she'll be presenting at the hydrology conference I think it's next week. So the other thing we're doing through Michelle's work and SAEON is trying to determine the relative impact of different vegetation units on the hydrological response. And for this, we need all this fancy equipment to measure the evapotranspiration of these different vegetation types. And one of the things that the communities were really concerned about was bush encroachment. So we've now initiated measurements on that as well, because they think maybe the indigenous trees and the increase in indigenous trees is actually taking a lot of water as well, and nobody's actually measured that. So we're honoring their wish, and we enhancing our research with that. Then all of this kind of work gets put into the ACRU model it's a gridded piece of information that Michelle knows a lot about and I know very little about, and then that has to go into ModFlow, which is a groundwater model. And we need somebody else to help us with the groundwater model. So I'm introducing you to Mkhulu Maseko. And he's looking at two components. So one of our questions is, where are different vegetation types getting their water from? And we think that the eucalyptus trees are getting their water from, they're very deep rooted and they're able to tap into the groundwater table on sort of a continual basis. And is the same true for the indigenous plants, or are they more shallow rooted with a more intermittent water use? So he's looking at that. And he's also responsible for doing the groundwater modeling. And he's been working under the very close mentorship of Bruce Kelby, who knows this area very well and has set up models for it in the past. But then all of this stuff needs land cover data. And when we started looking at the land cover data, we realized that there were some problems with it. And we roped in Keneilwe and Mark. And Mark has developed some amazing tools and techniques for assisting in sort of reclassifying and using a magic wand to help improve on some of the classifications and provide us with time slices of change over time in terms of the land covers. And his tool is also helping us to be able to very easily design and develop layers for the future scenarios of land use in the area. And then another input that we need, of course, is the climate. Now, we need a gridded, there is some station data available for the area, not a lot. So we needed to look at alternatives, and we needed essentially for the ACRI model, we need a gridded data set to help input into these hydrological models. And also what we need from the climate guys is 2 future scenarios of climate. And the bottom line is, and this is the elephant in the room, when we try and do research work related to climate change and future projections, is when you try and downscale a lot of these fancy global climate models to local scales, to the scales where people make decisions, the models are all over the place. They fall down, they're unreliable. And it's really difficult to say with any certainty what's actually going on. So they're rubbish. And we need a different approach to this. So the idea was we would use a scenario-based approach where we select 2 plausible climate futures, and then we create data sets for those. But there was a sort of a, well, how do we do that? And this has been a big tussle in trying to get this done. And essentially, when you're looking at the climate data, there are various different products. There's this CHIMP 6. Now, this is one that models the past climate and then also projects into the future. And what we'll be doing there is basically selecting a set of generally wet and take the mean of that, and generally dry and take the mean of that. There's also ERA 5 data. This is available as a product that's available for the actual past to current data set, but it doesn't project into the future. So I'm quite keen to look at this, but it's actually useless for the future projections. So then the other approach we're using for the future projections is to actually try and take the station data and mirror it backwards. And we can mirror it backwards in 3 different chunks, for example, or we can identify times in the past which were generally wetter or generally drier. So that's the approach we're taking at the moment with the climate work. So then we get the economic team. So I have to say that when we're having all these debates between the hydrologists and the climatologists, we get into finicky detail and we're talking about, you know, how reliable is it and all of that. And then the economists get into the room and they say this is all great, and basically that they generally don't generate a lot of data, but in this project we actually are. And their job is to try and pull together all these bits and pieces of information and unify it. But they tell us the scale is really coarse. So this is James Blichnow sort of warning us, you know, you guys are doing a lot of this very detailed stuff, but when it comes to the economic model, it's actually at a very coarse scale. And emphasizing the need that we really need a common dialogue and common vocabulary to be able to integrate across all these different components. So what we felt as a team is we really needed to try and do this integration up front. and we needed to start with the end in mind. So in terms of the economic model, this is just dummy data, but essentially what the end result of the project needs to look like is we say, right, here are a bunch of scenarios, and this is the net impact of these scenarios on the resource economy of the region. So this is taking into account the cost of the water, how people make money, the impact on various different livelihoods. And from this, you can look at the different scenarios and select, okay, well, which one is obviously going to be the optimum scenario for the future. So that's the idea. And the lessons from The Economist is that it's very frustrating for natural scientists. As I said, we go into all this detail, we try and figure out things to the last sort of decimal point. And James stands up and says, well, we're going to delete a lot of that. It's for the economic model, it's not actually necessary. But it is for understanding the system and the system dynamics. So there are all these different scales and levels of integration that have to happen. And James always makes the point that the actual factors that influence the long-term decision-making have got to do with cultural momentum, you know, what people are thinking and talking about, and also these disruptors, the magnitude and frequency and types of disruptors in the system. So with all of this, we've tried to put together this bit of a horrendogram. This is just to show you how we're trying to do the integration between the various different components and why we need all these different specialists and how they need to work together. And it's very much an iterative process. So we do a bit, we come back, we talk, we do a bit, we come back, we talk. We think we've sorted something out, and then we need to rediscuss. And it's very much a reiterative approach with a lot of interdependency. So it's like my brain, which is a spiderweb brain. So I'm quite comfortable in this space. And what I'll touch on next is just some of the economic survey work that we've been doing, and the interactions with the traditional councils, because the intention was to really make sure that the research work is embedded within the landscape, within the traditional councils, and reflects the aspirations. So we've held 3 workshops so far. And what we do is we introduce SAEON and what we do. We explain the project. And then we have a bit of a discussion about the trends in the rainfall in the lake and how the system actually works as a groundwater system. And we explore with the community members at the meeting climate change and their perceptions on climate change. And then we do a couple of activities. We ask them, what are your key challenges? What are you worried about? What do people talk about? And can you sort of identify 5 key ones that are most important? And then we ask how people make money and how they would like to make money. And then finally, we look at what would your future preferences be if you had the choice? And I'm not expecting you to read the detail of this, but essentially what's coming out very clearly is unemployment is a really critical factor across all the traditional councils. Second to that, water and the scarcity of water is a massive concern. And then there are a whole range of issues relating to land use. People are worried about the increase in blue gums. They're worried about bush encroachment. They're worried about lack of grazing land, which came up often and became a key leverage point that we identified in the area. And there are obviously a lot of concerns about lack of infrastructure and, interestingly, a number of social issues. Then when we look at livelihoods, what comes out really clearly is that people are making money out of the natural resources in the area. Yes, there are people making money out of the gum plantations, but there's a lot of reliance on natural resource for making money, as well as grants. But the lack of employment is clearly reflected here. The ones that are starred, so this is just a list of all the different things that people make money of, and the ones that are starred are the ones that people are making most money from. And then we ask about what sort of future, if you had a magic wand and like Mark, and you could change the land use, what would you change it to? And what we've discovered there is that people are interested in exploring a change in eucalyptus to macadamia. There was one group that had the idea of, can we take all the ukes out and plant marula trees? A lot of the groups we spoke to would like to see a conversion from eucalyptus to cattle grazing, and some are very interested in seeing a transition from eucalyptus to macadamia, taking either all the eucs out or maybe half of them. And some of the communities were even very concerned about the bush encroachment problem and wanted us to test the impact of that. And then we had the option in there of how many of you want to increase your eucalyptus plantations. And so far in both the workshops we've had as well as the community surveys, not a single person has responded that they want an increase in eucalyptus. So I went back to the team and said, right, I've got a whole bunch of scenarios for you guys to model. And they told me I was smoking my socks. And we needed to just start with the basics. So essentially what we're going to be doing is just looking at the contemporary land use. And we're going to start with that and do the modeling process from beginning to end to see how it works and make sure we've got all the connections right. And then once we've done that and got all the technical links right, then we will start to roll out further to these other ones. And then just briefly, we're busy doing the household and sector surveys. We're getting amazing data in from that. We've done over 3,000 households. This information is going to be populated into an economic model, which is very flexible and still under development. And essentially, the net result is we can explore with communities decisions you make now, the different outcomes of different decisions on both their water security and their economic income. So the big idea, have we managed to actually do anything? Have we seen transformative learning? And has anything emerged from this that wouldn't have possibly emerged if we'd been working alone? And from my perspective, the answer has been a resounding yes. When we listen to issues and we couple that with giving information on climate change and how the system works, and you make these linkages between the land use, the climate, and people's concern about water security, we see big attraction. And through the workshops, we've also identified leverage points for opportunities for change. For example, cattle grazing. People want more cattle grazing, but they haven't done it because there are no watering points. So we can put in watering points, and then that'll solve the problem, and they'll stop converting grasslands to eucalyptus trees. We wouldn't have figured that out if we hadn't been working with the communities. And our team is becoming transformed. The people who are working in the field saying we need to be the voice of the people. And by creating this space for respectful dialogue, we're starting to see in the science space where people are working together, people are starting to share information that perhaps ordinarily they wouldn't have shared in the past. So just to end, there have been lessons. We definitely need each other. Flexibility is key, and be prepared to suspend your assumptions and your opinion. And building trust and relationships is great. And essentially, we need to start the integration early on, work across different groups. We've got our group, but we're also working across a whole lot of other groups operational in the area. And really, it's all about having fun. So I want to just invite you all. The Northern Maputaland FTON landscape is open. This project is just the start of something we hope that's going to be much bigger. And I want to just sort of any input you have or advice to bring us together and come and help us develop these programs so that we can actually have a positive impact in society. We really welcome you to do so, and I challenge you to come and help us and learn together for a better future. And with that, I will close. Thanks very much for listening.
Thanks, Sue. That was great. Can I open the floor for questions? Anybody? If you just pop your hand up or unmute and you can ask. Stephanie. Go ahead.
Unmute. Okay. Good morning, everybody. Thank you. That was such a wonderful talk. I work at the NRF for my sins. as a family, we've been scuba diving at Sodwana since 1990. And obviously, you can't dive the whole time, so you investigate the area and spent many hours on Lake Sibaya and Shazibi. And we've often wondered why nobody in the area seems to have investigated hydroponics as a form of agriculture and income. Obviously then recycling water, possibly making use of solar power to run that whole system. Aware of cotton that was grown at the foot of Jacini, the pineapples at Shlishlui, and at one stage there was a cashew nut farm, but I think that's closed now. But hydroponics was the thing that sprang to the collective family mind.
Absolutely, and there is actually interest in that. So in some of the council workshops that we had, people, when we said, well, what kind of things would you like to do in future? One of the things is we want to learn how to do that sort of work. Some people even were interested in fish farming.
Yes.
And so one of the key constraints in that area is lack of infrastructure. There's not an even distribution of power. There's very little infrastructure, and what we've realized is people have ideas, but the step between transforming that idea into a business plan with the appropriate skills to getting the funding to then implementing it, you need that full value chain. And it's something that's come out in the research. When you go into the communities as a researcher and you start talking about these things, the immediate perception is you're a researcher dealing with a problem and you should be able to solve it. An interesting example, when we explained the climate change issue, a lot of the people there felt climate change wouldn't affect their area because there's no pollution in their area. And then when we explained, okay, well, that's not true, and this is how it works. And they say, but you guys are clever, you can fix this problem, just fix the climate change problem. So there's an expectation that as a researcher, you can do it all. And my lesson in this is there are solutions out there. For example, if we could implement watering points for cattle, we would need power, we would need to sink boreholes, we would need a good grazing management plan. I, as a researcher alone, cannot do this. And what you're highlighting is the need for us to make connections as researchers across the value chain, from identifying the critical issue, doing the research, but then the implementing agents and the action-based research projects. We really need as a community, I think, if we want to have impact, to be able to forge those connections across the value chain, from the research work to the policy, to the implementation. And at each step in that process, the people in the community need a sense of ownership and empowerment of that. So there are things to look at in that area, but it does require a collective will. And there's also, as I said in the beginning, there may be logical solutions, but there are other dynamics at play that need to be addressed before you see those switches in people's willingness to accept an alternative. But absolutely.
The other thing we were often wondering about is the influence of the tribal trust, which is very influential in that area.
What do you mean by tribal trust?
Well, I know Sodwana is owned by a very big tribal trust.
Yeah, so in that area, the entire region is Ngonyama Trust land, which is owned by the Zulu King.
Yes.
And it's managed for him through his chiefs. And we're working in 3 different traditional councils, in Mbila, Mabasa, and Tembi. And what's been really interesting, that they don't own the land, they hold it in custodianship, and there are formal structures through customary law through which they should operate and should make decisions. But what's emerging both from the council meetings and from the household surveys is the dynamics in those three councils are very different. And part of it's got to do with how it's managed, and part of it's got to do with whether they've got access to resources. So for example, in Sodwana Bay, we're finding a lot of people, because they've got access to the coast and there's a big tourism industry and people like Stephanie go diving there, there's actually a lot of employment through that, and people have more disposable income. If you move across to the west, to the Msileni side, where they don't have access to the coastal region, people are far more reliant on natural resources. They don't have disposable income, and poverty levels are a lot higher. Then you go to the north, and we actually had one of the council members saying one of the reasons why there's a lack of infrastructure development here is perhaps because there's one person in charge of such a big area. So that's what I was alluding to when you're having a research project and you have sort of a neutral space where you can start have these dialogues, these issues start to surface in a safe space where people can actually talk about it. We had people standing up saying, you know, Mondi and Sapi are pushing us to do this. We don't want this, or many of us don't want this. And you start to see these sort of opposite stances where some people are saying, but we want the ukes, and others are saying, but no, we know it's damaging. And how that plays out is important. So yes, it's all tribal land, and through these dialogues and through embedding our research in the area, the hope is that you create this critical mass of dialogue to actually shift perspective and perceptions to something more constructive.
Thank you. Thank you very much.
Great, thanks. Any other questions for Sue?
Hi, Sue. Thanks for an interesting presentation. Lots of questions, but I just thought I'd ask one. How do we know you're measuring? How do you know you're measuring the right things? Because there's different scales that you're working at. So, I mean, one of my questions was linked to the data that you had available. So the one was, most of these types of analysis are done with either census data collected at a national scale, or the land cover, national land cover data, and you taking it sort of a level down. So I was wondering, how different would those two data sets, you know, what type of outcomes would you expect from those two different data sets? And then also, you know, how do we know we're measuring the right things? Because if, as SAEON, we've got this sort of biogeochemical network of measuring, and but there's another lens of the economic assessments or vegetation or water. I don't know, it's a complex system and lots to measure. So how do we focus? Or have you found that to be a challenge in this project, I suppose?
I think it was Einstein who said we have to do research because we don't know what's going on. So yes, what we found, certainly for the land cover, is when you're working with national data sets and you try and downscale it to a local area, it falls down. And Mark has been instrumental in trying to help us address that. So, and it's the same with the global climate models. When you try and downscale them to develop scenarios, that they just don't work. And as I said, this is the elephant in the room. When you're using these international or national products, which look very sexy on all our reports and paper, and you really try and use it for decision making at the level of the institutions where people make decisions, there's a major mismatch. And that was part of our motivation for kind of working from the ground up. And how do we know we're measuring the right things? We ask people. So the different components to that. So half the reason around having the traditional council workshops is to try and get a perspective. What are the talking points? What are the critical issues in the area? And then that was used to actually inform the design of our household and sector surveys. So for example, employment, which is the obvious one, how would a wet year affect your employment? So we used it as an iterative approach to try and get at what are the critical issues we need to look at to see if we can get a response in relation to past stresses related to climate. And then in terms of the scales issue, what we've been doing a lot of, and this now falls beyond my scope, between the climate modelers, Chris and Ross, and Michelle and Seifu and Kulu, is really sitting with pieces of paper and trying to figure out, okay, what does your grid look like and what does my grid look like? And I think Michelle can come in as well. And getting the spatial scales for the biophysical modeling right has been the key point of integration and where some of the advances have been. But it's beyond my scope of expertise to be able to talk to that sensibly. I think Michelle can chip in if she wants to.
No, thanks that
on that, yeah. That's and in terms of, I think the what we know in terms of are we measuring the right stuff, when you look at models, our approach at our node has always been, what are the things that the models are sensitive to that if we get wrong, it's going to have a big knock-on effect. And where those are generally proxied, we want to go in and measure that stuff, which is why we've invested in the carbon in the water flux work, is to actually measure our in situ parameters for our conditions locally, rather than using some arbitrary coefficient developed by FAO. I don't know if that helps.
No, it does. Thank you.
Okay.
Ryan, any other questions, or did that answer what you had?
No, it's good. It's a nice, a good answer to a complex question. Thank you.
Great. Any other questions for Sue?
Come on, guys, bring it on.
Maybe one more.
Okay.
What's the time? Oh, okay, still time. The trade-offs, the question with trade-offs and ecosystem services, did you pick up any sort of conflicts or issues?
Yeah. Oh yeah. So the modeling hasn't been done yet. But what's emerged is very clear from the aspirations, both in terms of the traditional councils, who are the leadership and the decision-making body. So we go and we speak to them first, and then we go and kind of benchmark that with the people on the ground and their lived reality. And what's emerging is a lot more people want to do cattle farming, and the space for cattle farming is becoming less, and that's partly because of the distance to water. So historically, there would have been surface water all over the place. Now, because of the drought and the eucalyptus trees and the water table declining, that water isn't available. So there's a perception that there's less space. So if you can put in watering points or improve the water table, then there'd be more cattle. But there's conflict. For example, a lot of the plantations get burnt, and they get burnt by people who are farming cattle because they know that the eucalyptus take water, so they set fires to the plantations. And so there those dynamics we're starting to pick up. And also in terms of the household surveys, we're seeing the importance of wetlands as critical resource areas. I think in ecological theory that they talk about key resource areas. So in times of drought, those wetlands become absolutely vital for poorer households to sustain themselves. And if those are compromised beyond a particular tipping point, it becomes problematic. So we're seeing that kind of dynamic play out. And yeah, that's all linked to the water table. But then at the same time, so what's actually happened is the water table used to be really high and people could farm in wetlands all over the place. And as it's come down very low to below where it's been in recorded history, it's opened up areas in swamp forest, and there's now conflict between conservation and communities, where communities have gone in and they've cleared swamp forest, gone in and planted there in the protected area. And then there was a big rainfall event at the beginning of the year, you all know about it, and now they're complaining that the areas have been flooded. So these wetlands are very marginal habitat for, they're important, but they're high risk areas. And if you're only dependent on those, and if all your wetlands are either dry or flooded or burnt, it really is, I think we're very close to seeing an ecological tipping point, which is why we need to look for alternatives.
Thank you.
Thank you very much, Sue. I think that sort of brings us to the wrap-up time. So Sue, thank you very much for a very interesting presentation. I hope when the project closes that you will give another presentation on the final outcomes. And thank you to everyone for being here and joining us this morning. I just want to give an advert for the next seminar, which will be given by Mark Pienaar on the 4th of November. Mark's from the Vazi node, and he's going to be presenting on FW initiative on mobilization of freshwater biodiversity data via GBIF and the potential use in measuring status and trends at a global scale. So please also jot that down and join for that one. Great. Thanks for everyone.